Hi, I'm Josh.
And I'm Jackson.
This is Enigma Explained. Cool. So we're going to start this video with an example, and we're going to have some rotors, and we're going to observe how they turn at each step. So our alphabet only has letters A through C, and we are going to have 4 rotors, and we're going to number them 1 through 4. So we have rotors 1, 2, 3, and 4. And each of our rotors will have a notch on its ring at the C position. So rotors 1, 2, 3, and 4 all have a notch at C. We're also going to have 3 poles, and we're going to number these based on the rotors they are attached to. So since our 3 poles are going to go with rotors 2, 3, and 4, we are going to refer to them as pole 2, 3, and 4. So 3 poles, 4 rotors, and there is no pole for the first rotor, rotor 1, which remember is to the far left, so therefore that rotor will not rotate. So initially, all of our rotors will be starting at A. So we can start off here with A, and we're going to see what happens for the next few positions. So when we start off at all A's, each time we're going to see, are any rotors at a notch, and if so, which rotors should be turning. So for our first step, only the fast rotor, only that pole is going to succeed with engaging with its ratchet, so only this rotor will turn. All the other rotors are not at C, so nothing is at a notch, so we will have A, B. Cool, so first one is done. Now again, we're going to say, are any rotors at a notch? Nothing is at a notch, but the fast rotor always succeeds because there is no ring blocking its pole from engaging with its ratchet, so we will have A, C. So now we're again going to say, are any rotors at a notch? And we observe that the fast rotor is indeed at a notch, which means that the rotor next to it, so this rotor 3 here, its pole is able to engage with its ratchet. So rotor 3's pole can engage with rotor 3's ratchet through the alphabet ring of rotor 4, which means rotor 3 is going to turn in addition to our fast rotor turning as normal. So we're going to have A, B, since rotor 3 is turning, and then A, since our rotor 4 always succeeds in turning. So what happened here, we had a notch here, rotor 3 was able to fit into this notch, turn rotor 3's ratchet, which changed it to B, and then our fast rotor changed from C to A. So at the next step, we're going to say, are any rotors at a notch? That's a no, so we're going to end up with A, B. Again, fast rotor always succeeds. And again, we're going to say, are any rotors at a notch? No, but the fast rotor always succeeds, so we have A, B, C. So are any rotors at a notch? Yes, rotor 4 is at a notch, has a notch at C. So a rotor 3 will be able to have its pole engage with its ratchet and turn rotor 3. So rotor 3 will be turned to C, and our fast rotor will succeed again, so we will end up with A. Now, this is a pretty important part here. So I have a notch here on rotor 3, and we know that if kind of rotor 3 has a notch, that means rotor 2's pole can slip into that notch and turn rotor 2's ratchet. But if we remember Jackson's video on double stepping, so this part here, the video right before this, when a rotor's pole can slip through the rotor to the right's notch and turn its own ratchet, it also turns the rotor to the right because it is engaged with its alphabet ring. So when rotor 2 turns from A to C, since it is able to turn its ratchet, from A to B, this is also going to turn rotor 3 from C to A. So we have like a double step here. That's where double stepping comes from. So A to B, C to A, and then as usual, we turn our fast rotor from A to B again. So what happened here, and this is our double stepping right here. So we're going to say, are any rotors at a notch? No. So only rotor that changes is the fast one, A, C. We have a notch here at C, which means rotor 3 will be able to turn in addition to our fast rotor. So A, A. So A to B, C to A. We're going to turn our fast rotor, going a little faster now, A, B. No notches, so the fast rotor again, A, B, C. Now we have a notch on rotor 4, so rotor 3 will turn, so A, B, C, A. So we've again come to a point where we have a notch, not just at our fast rotor, but actually in the middle here on rotor 3. So when rotor 2 is slipping into rotor 3's notch, not only will it turn rotor 2, but also rotor 3. So we're going to end up with A, C, since we're rotating B to C. Our C here will rotate to A, and our fast rotor will also rotate to B. Cool, so looks like we'll keep doing a few more until we wrap all the way around. So since there is no pawl on our first rotor, there is no pawl that will slip into this first rotor's ratchet. So the fact that there's a C here does not mean we change this first one to B. So it does not end up like this. Why, you ask? There's no pawl on rotor 1, and there's no way to turn rotor 1's ratchet. So this remains at A. The C stays. A, there is no notch to the right, but the fast rotor changes to C. Now we have a notch here, so I will have A, C, B, since rotor 3 turns because there's a notch to the right, and the fast rotor turns again, so C to A, C, B, B, since our fast rotor turns here, A, C, B, C, since again our fast rotor turns from B to C. We have a notch on rotor 4, which means rotor 3 will turn in addition to rotor 4, our fast rotor, so A, C, C, A. And now rotor 2 has a notch to the right, meaning it will turn both rotor 2 and rotor 3, so we will end up with A, B. Kind of bring us all the way back around to where we started, B from A. And that's about as far as we're going. So, little conclusion here. So we see the fast rotor rotates every time because there is no ring to the right that stops it from engaging with its ratchet. We see rotor 3 advances when rotor 4 is at C, since all rotors have a notch at C. So yeah, when rotor 4 is a notch at C, pawl 3 engages with pawl 3's ratchet and advances rotor 3. Then we're going to talk about double stepping here. So rotor 3 advances when it is at its notch because the pawl to its left will push against the notch in rotor 3 in addition to rotor 2's ratchet. And there is no pawl for 1, so rotor 1 does not rotate. Cool, thanks for listening, and we'll be back with another video shortly.